So let us consider if you have a blanket which is spread in the top of the room. So suppose if you pour water in the blanket, what will happen? It will start dripping and it will go towards the downhill. So this point is, if the blanket is like this, if you pour water, the water will drip down and go where there is a downhill like this. So this is called as, the direction of this is called as maximum descent. Suppose if you are looking at the opposite direction, the direction where it is coming, this direction is called as maximum ascent. So there are two parts in the same line. This is the blanket. So the downward direction is called as direction of maximum descent. The upward direction is called as direction of maximum ascent. So the direction of maximum ascent is called as a gradient. The direction of maximum descent is called as negative of gradient. Negative of gradient or negative gradient, simply. Suppose you have a hiker is trying to climb the top of the mountain. He is going towards the direction of gradient. Otherwise, there is a stream of water flowing downhill as quickly as possible. Then it is following the direction of negative gradient. Is it clear? The direction of gradient and direction of negative gradient is clear. Direction of gradient is towards the maximum ascent. Direction of negative gradient is towards the direction of maximum descent. So how much we are going uphill or how much slowly we are going downhill, those, not only the direction, we can also find the magnitude or strength or size of how much we are going uphill or how much we are coming downhill. Just like the derivative, we can also find the gradient. So we can use the gradient to find the local maxima. At the top of the hill, there is no gradient. So at that time, the gradient will get vanished and we can find that is the global maxima or the local maxima. Similarly, at the bottom of the hill, there is no gradient. So that can be the local maxima, local minima or a global minima. At the bottom of the hill and at the top of the hill, the gradient gets vanished. So that is a point where we will find the local maxima or local minima or global maxima or global minima. When we are in the plateau, there is no gradient at all. So there is one more situation. So if you look at this one, these points look like a top of the hill from one direction. If you look at this direction, it is located at the top of the hill. If you look at from so the same point will appear that it is appearing at the top of the hill and at the bottom of the hill. So this point is called a saddle point. Saddle point means at one point it is looking at the bottom of the hill, and other point it is looking at the top of the hill. At the saddle point, it is looking like a flat area, a plateau. In the plateau, there is no gradient. So similarly, at the top of the hill and the bottom of the hill, there is no gradient. So this can be local maxima, and at the same time, it can be local minima. So in neural networks, the networks adjust the numbers that control them in an effort to follow the negative gradient. So there can be less error as possible. So we will see about how neural network is using gradient to control their numbers. We will see in the later classes. So, but for now, you understand the term gradient. Gradient is the generalization of the derivative in three-dimensional or in higher dimensions. Gradient is used similar to derivatives. It is used to find the local or global maxima or minima. If you understand this one till now, that is enough. Is it clear? So what we saw about the curve is that we wanted to study about derivatives and gradients. So we saw the definition of the curve, which is continuous, smooth, and single value. And we saw what is derivative. Derivative is helpful to find the local maxima or local minima or global maxima or global minima. Then we saw about tangent line, how tangent line is used in identifying the derivatives. Then we saw how to find the local maxima and the local minima. Then we saw what is gradient. We saw the definition of it, and we saw what is the direction of maximum descent, what is the direction of maximum ascent. We saw what is gradient and what is the negative gradient and how to use that one to find the local maxima and local minima. And we also saw about the saddle point. Is it clear now? Am I audible?
Yes, ma'am.
Okay. Now let's go into the next topic, data preparation. We'll talk a little bit of data preparation and we will take this in the next class. Anyone would like to talk about what is data preparation? Any idea about it? Anyone would like to tell? You can guess what is data preparation, why we need to talk about it.
Ma'am, can I try, ma'am?
Yeah, please.
Ma'am, data preparation, I am guessing the answer, ma'am. To upload it into the algorithm or the machine, we need to prepare the data in certain way which is acceptable by the computer.
Excellent. Then any other thing?
Be classified in an orderly fashion. Like you cannot have jumbled things. So when you're having either when you're talking about a graph or something, it should be in a smooth way where you can arrange in an arrangeable way.
Okay, ma'am, in a structured way.
In a structured way. And then you also talked about entropy, no? So maybe those factors should be also taken care of. You should not have high, at least you should try to arrange it in such a way that you include all forms of variables also.
Yes, ma'am. So making it suitable for the computer to process the data, making it in a structured way, or arranging the data. Any other thoughts?
To establish
Sorry, sir, your voice is low. Can you be loud?
establish ground truth.
Uh, I'm sorry,
I mean,
not
I
able to
can't.
hear.
To establish ground truth.
Okay, to establish ground truth. Any other thoughts? Anyone would like to try?
I think you need to clean and validate the data.
To clean and validate the data. Then
Deal with missing values.
dealing with missing values. What is the goal of data preparation? Anyone would like to try in that way? Why we need to prepare our data? What is the goal, end goal?
Data analysis.
Okay, data analysis. Okay. So we all know Machine learning is nothing but garbage in, garbage out. So whatever data we give, it has to be as much as accurate as possible. So because our output depends on what we feed. So our data has to be clean. So all these points are correct. So we have to make it suitable for our computers. It has to be arranged in a proper way. To establish ground truth, we have to prepare. We have to clean the data. We have to deal with missing data. And of course, we have to do analysis on the data. So all these points are correct. The most important point is that the accuracy of our output depends on what we feed in. So we have to make sure we are giving a clear data, clean data to the system. Data preparations can sometimes be called as data cleaning, data cleansing, or data scrubbing. It can be called by these names also. So because most of the time our data comes from noisy sensors, damaged hard drives, simulation programs with bugs, or even sometimes from incomplete transcriptions or from paper records. Most of the thing comes from paper records. Some human will convert the paper record into a digital format. So that time human induced errors can come. So we need to look into our data. We have to massage it and we have to fix any problems with it. Because if any problem in the data, then our outcome will also be a problem. So how much accurate our data is there, that much accurate our final outcome will be. So there are a lot of tools that are available in machine learning to clean the data, to prepare the data. So there are rich methods available for doing this job. Such techniques are called as data preparation techniques. So any method you follow, the first step in the machine learning algorithm or data science projects is data preparation. So it is essentially we are trying to pre-process our data before we learn from the data. We have to pre-process the data so the learner can use the data most efficiently. So data preparation is essential because most of the learners when I say machine learning methods are numerical. So we have to prepare the data. Data cleaning is one aspect of data preparation because it is we have to structurally arrange a way. Cleaning is also one aspect of it. There are multiple aspects in it. We will see what are the different aspects of data preparation. We will see all those things in this chapter. So it has a strong effect on the information which we handle. So that is the thing. And in data preparation, what we are essentially doing is that we are transforming the data. So what is data transformation? When we automate the data cleaning process, we will often include some transformation that will modify the data which we are working with. So while preparing the data, we will modify our data. We will transform the data. This modified data only, we will give it to the algorithm or to the machine. So if you are modifying the training data, you have to modify even your test data or any future data by the same transformation. So whatever transformation you are applying to the training data, you have to apply the same transformation to the all future data or the test data. So transformation is usually scaling all those numbers, shifting their mean, eliminating some unnecessary data. We will learn whatever things are going to do. This transformation can be anything. It can be scaling, removing unnecessary data, shifting their mean. It could be multiple things. We will learn some of them in this class. So how we will apply this one is that first we will have a training samples. So typically what we will do when training samples are given, we will examine all the training data we have got. We will decide how to modify it. Then we will apply the modification. Then we will use the modified data to train our model. then we will apply the same exact modification to the new data before giving it to the algorithm. This is how the process is. So we will take the training data, we will analyze the training data to decide what kind of parameters we need to change. So then we will determine the transform parameters. Then we'll give it to a data transformer. Then we will give it to the model and we will get our predictions. So this is for the training data. For the test data, what we will do, we will not decide what kind of parameters we have to choose for the test data. We will take the test data, whatever parameters were applied it, you apply to the data, the same parameters you apply to the test data also, and then you will feed it into the model, and then you will get the predictions on the test data also. This is very important point. So whatever parameters you decide for the training examples, you have to retain the same parameters for your test data set also. You should not use here one and here one. Then there will be difference in the outcome. So you have to use the same transform parameters to the test data also. How do you decide the transform parameters? You analyze the data and then you decide what transform parameters need to be present. The rule is to remember this. We have to determine how to modify our training data, modify it, and remember how we modified it. Then we have to apply it to the test data. For example, let us have a small example. So you have cows and zebras. So you have a black and white cow and you have a zebra. So both cow and zebra look alike, right? They both have a single head, single tail, four legs. They have almost equal sized. This is also black and white. This is also black and white. Then how can we differentiate both the things? You analyze the training data by looking at the pictures of the cow and you look at the pictures of the zebra and you analyze it. Then you come to a pattern that based on the pattern, visual pattern, the texture pattern of the body, you can differentiate cow and zebra. You come to the conclusion. Then you decide you have to extract patches from the training data set. So when coming to the test data set also, you should extract the same number of patches to do the prediction. So you cannot do something in the training and you cannot change it in the testing. So you have to do the same thing both in the training data set and in the testing data set. Is it clear? So next, we will look at the types of data. So every sample has a list of values, which we call it as features. So these features can be numerical or categorical. Numerical means numbers. It can be integers, floating point, or something. Categorical means it has a label saying, for example, cow, zebra, or the labels given to it, with distinct characters which are given to it. In categorical, there are two types. One is ordinal data. The other one is nominal data. So there are two types in categorical. So the features can be categorized into two types of data. One is numerical data and categorical data. Numerical means numbers, categorical means labels. So the categorical data has two subdivisions. One is ordinal data, another one is nominal data. So ordinal data means in nature they have an order. For example, rainbow colors has a natural ordering in the system. So otherwise you have a different age groups, infant, toddlers, teenagers. So based on the age, natural order, they have a categorization. So they have an order inbuilt by nature. Nominal data, on the other hand, is a categorical data which exists without any natural ordering. Suppose the desktops item, examples of desktop items like paper clip, stapler, pencil, sharpener, rubber, all these don't have a particular order. So they all come under nominal data. You can convert the nominal data into an orderly data by presenting an order for it. Suppose if you take clothing items like socks, shirt, glove. This is a nominal data. Suppose if you fix an order, that order should come from head to toe. Then you can start writing like hat, shirt, socks, sorry, gloves and socks. So when you fix an order to the nominal data, it becomes an ordinal data. In machine learning applications, we convert both the ordinal and the nominal data into numerics and then we apply to our system because it is easy to deal with new numbers. So most of the time, we will convert the categorical data into numbers and then we work with computers. So we assign a value to the category and then we apply it to the computers and we work with that one. Is it clear? So we just started with the data preparation. In the next class, we will see in detail about different methods used in the data preparation. Any doubts? Is there any doubts?
No,
Okay, ma'am. Thank you all.
thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.